This is segment 6 of the Module 2 lectures. In this segment, we're going to talk about the histogram and the polygon plot. So the frequency distribution of a numerical continuous variable is displayed using a histogram, or as we see later, a polygon plot. So a histogram is like a bar graph where the frequency, relative frequency or percentages are on the vertical axis and the bins or categories on the horizontal axis. The bars in the graph are adjacent to each other, and so are right next to each other, and their height corresponds to whatever you're plotting on the vertical axis, either the frequency, the relative frequency, or the percentage. Going back to the example that we talked in the previous segment about the prices of an item, if you recall, we produced the frequency distribution for the data that we had there on the prices of an item. And so what we do in the histogram, we take this boundary, lower and upper boundary values, and we put them on the horizontal axis. And in here, this is the lower boundary, and this is the upper boundary up here. And then we draw the bar to match the frequency. So for the first boundary, the bar goes up to a frequency of 2. The next bar, from larger than 380 to 390, goes to a frequency of 11. And the third bar goes to a frequency of 7, as shown here. So this is what we call a histogram. I'm sure you have seen this. These are very common graphs. Now let's talk about the polygon plot. So this is the histogram. The polygon plot is a simple graph where we add segments that connect the midpoints of the different classes. And the difference with the histogram is that we need to include another class below the first class that we have in the histogram, and another class that is beyond the last class in the histogram. And the reason for that is because this line always starts at 0 frequency and it ends at 0 frequency. And if you notice, the line goes from the middle of the first class, from 360 to 370. The middle is 365. And that line goes to the middle of the next class, or bin, which is 375. And then the next line goes from 375 to 385, and so on. So we're connecting the midpoints until we reach a frequency of 0 again. So really, the polygon plot displays the line that connects the frequencies, relative frequencies of percentages, at the midpoint of adjacent bins in the frequency distribution, or adjacent classes. And so the polygon will look like this, not like this. Here I just superimposed the polygons to show you what it represents with respect to the histogram, but we typically will draw it like this. So we have two graphs that we can use to represent the frequency distribution for continuous data. Now, another important aspect of histograms is describing them by using their shapes. So these are the typical shapes, and these are the shapes that we will refer to in our homeworks and exams and quizzes or whatever we do. So we have, in this case, we have a symmetric histogram. Symmetric because if you find the middle point, and if you fold this figure on that middle point, the line that connects that middle point, then you will see that two sides are identical to each other. This is another symmetric histogram, but the difference is that all the bars have approximately the same height. And this is called a uniform shape, because the frequency is uniform across the different classes. Also, we have what is called the left or negatively skewed histogram. In this case, the bars descend towards the left or towards the negative numbers. And that's why it's called the left skew or the negatively skewed histogram. And a right or positively skewed histogram now has the opposite, or the mirror image of the left or negatively skewed, because now the bars descend towards the right or towards the positive numbers. And finally, we have something called the bimodal histogram. And these are not very common. I have found this in practice, especially in manufacturing, where, for example, let's say that you are measuring the weight of detergent in some particular size of bottle. And you say, well, why do I have these like two curves if I'm filling these bottles to the same amount? Well, typically this happens because you may have two machines filling these bottles. And unfortunately, these machines are set to dispense supposedly the same amount, but they are different enough that you can see the two, like the two histograms put together. Even though you're measuring the same quantity, the actual quantity varies from which machine the bottles come from. That's an example how you will encounter this bimodal histogram. Now, if you use the polygons, often we like to use the polygon plot because it's easier to sketch. On the blackboard, you can just sketch it. So, well, here's a symmetric shape. And you can see that if you cut it in the middle and fold it, then the two parts will be the same. I mean, if you mark the center point and you fold it over that middle point, then you will see the two sides are identical. And the uniform, well, is just a rectangle showing that the frequency is constant. And this will be a sketch of a negatively skewed or left skewed distribution. And this will be right or positively skewed distribution. And this will be like the bimodal distribution. This reminds me of the logo of that Twin Peaks bar. And I always tell my wife, oh, look at that, there's a bimodal distribution. And she looks at me like, what? Well, she's getting used to my statistical jokes. But this is what I think about when I see this, whenever I see the logo for the Twin Peaks bar. All right, so again, we may use histograms to show the shapes, or we may show these polygons to show the shape. All right, if we go back to our first example, then the question is, and if I go back, I'm talking about this example right here. So I didn't talk about how to interpret this histogram because we haven't talked about shapes and all of that. So now let's talk about the shapes and what the histogram is telling us. So what would the shape of this be? Well, I don't think it would look like a symmetric one. I don't think it looks like a uniform histogram. I don't think it looks like the bimodal. And if you see, the bars are decreasing towards the right. So this looks a lot like a right skewed or positively skewed histogram. So, well, that's great. If you are talking to the manufacturer of this item and say, oh, your histogram is skewed to the right, then he might say, so what? How does that help me? So we need to explain this in more practical terms and think about, you collected the data, you created the histogram, and now you go and talk to the manufacturer of this item and he said, well, this is what I found. Well, how would you tell him what you found? Well, you can tell him that, for example, the majority of the retailers sell the item at a price above $380 up to $390. Then that's 11 of the 25. And then that 7 of them sell it between a price bigger than $390 up to $400. And there is only 2 retailers that sell it for $380 or a lower price. And there is only 1 retailer that sells it above $410. And so you can go through this and tell this person. And now if you want to use the shape of the histogram, you say, well, it seems like people seem to tend to sell your item for a bigger price. And then when the manufacturer sees this, I say, well, maybe I should go and talk to these retailers, because why are they selling it so expensively? And why is this guy selling it at a lower price. How can I get this perhaps to sell at a lower price so I can better compete with other manufacturers of the same item? So again, get into the habit of explaining not only the shape, but what the histogram is telling us from the practical point of view, and typically within the context of the problem that we are addressing. All right, so I hope that this is helpful. This is example 1. Here's another example. This is, if you remember, in module, at the beginning of this module, I show you the bank data with 2020 observations. So in this case, we created the histogram for the time it takes to process a loan application. And again, the classical question, what is the shape of this histogram? And I think there is no question that this is a right skewed or positively skewed histogram. See, the bars are just descending towards the right. Well, great. What can we say about the efficiency of this bank if their goal is to process their loans in less than 7 days? Well, you can see that only in these 2 cases, the loans are processed up to 7 days. And again, we will need to see how this was constructed, and probably this is to less than 7 days. And this is more. The next bar is from 7 days to 9 days. All right, so if you look at the frequency, there are about let's say close to 400 applications that were processed between 3 and 5 days. And there are about 500 that got processed between 5 and 7 days. So you say, well, near 900 of these applications were processed within the desired time. But there are 2020. So this is less than 50% of the loans that are processed at this bank. So clearly, this bank has a problem because it's not meeting its goal. In fact, there are cases where you almost take a whole month to approve a loan. Only a few of them, of course, but you can see they are taking much longer than 7 days. This other 50%. So the bank needs to address the issue of how they process this loan, look at these loans that took a long time to be processed, and figure out why is that happening? How can I streamline the process to get the loans processed faster? But this is how you would use this histogram and talk to the bank manager and says, well, here is an issue. You are not meeting your goal, and you really need to streamline your process so that you can get the majority of your loans processed within the desired 7 days. Here's another example. Now this is the amount of those loans and the applications. And you can see this is somewhat symmetric, but still you can see this descending to the right. So again, I will argue that this seems to be a little more skewed to the right, with the majority of the loans between $14,000 and $100,000. So very few exceed the $100,000, these 3 cases, and very few are below $14,000. You can see that the most common amount of the loan is between $34,000 and $44,000. And again, you can tell the bank manager, well, this is how frequent the amounts are of these loans. And then you may look at these high-value loans and see if those are somewhat related to the loan processing time of the loan. Okay, so this is the end of this segment. And again, as I told you before, pay attention to how you could interpret these histograms and these frequency distributions. Thank you.